This video is about using segment addition to solve for a missing variable. So in segment addition, if B is between AC, then AB plus BC equals AC. So what that means is that if AB has a length of 5 and BC has a length of 7, when we add them together, we're going to get our total length of 12. So we can use segment addition to solve for a variable. So in number 1, we want to solve for G, and then we want to find the length of AB. So AB and BC are the two pieces of the line, and AC is the whole line. So we would have 6G plus 14 plus 4G equals 74. We're adding the two pieces together to equal the whole thing. So we get 10G plus 14 is equal to 74. We can subtract 14 from both sides, so 10G is equal to 60. So when we divide, we get G is 6. Then we want to find AB. So to find AB, 6G plus 14 is representing AB. So to find AB, we're going to substitute 6 in for G. So 6 times 6 plus 14. 6 times 6 is 36. Plus 14 will get us a length of 50. In number 2, we want to find W and then find RS. So the two pieces that are equaling the whole line here are the 9 and W squared minus 43. So 9 plus W squared minus 43 is equal to the whole line of 7W minus 4. So when we combine like terms, we get W squared, and then we can combine the 9 and the negative 43. So minus 34 is equal to 7W minus 4. Because there's a W squared, this is going to be a factoring problem. So we want everything to the W squared side. So we get W squared minus 7W minus 30 is equal to 0. So we need two numbers that multiply to negative 30 and add to negative 7. So we're looking for one of each sign. So we have W minus 10 and W plus 3 is equal to 0. So as we solve, we're just going to switch our signs. So W is 10 and W is negative 3. Now, in geometry, you have to make sure do both of your solutions work. So if I put negative 3 back into one of my places where the variable is, so either one of these, 7 times negative 3 minus 4 is negative 25. You cannot have a negative length, so this solution is not going to work. So if I said what is X or what is W, it's only going to equal 10 because negative 3 doesn't work in this situation. Okay, then we also need to find RS. So RS, now that we know W can only equal 10, is going to be 10 squared minus 43. So we get 100 minus 43 gets us 57. In number 3, solve for X and find BD. So as we are solving for X, this time our large segment AD has 3 pieces to it. So we're going to add all 3 pieces together. So X plus 3 plus 2X plus 5 plus 5X minus 4 is equal to 12X minus 20. When we combine the X's, we have X, 2X, and 5X. So 1 plus 2 plus 5 gets us 8X. And then we have 3 plus 5 minus 4. So that's going to be positive 4 equals 12x minus 20. So we can move our x's to one side by subtracting 8x on both sides. So we get 4x. And we can add 20 to both sides. So we get 24 equals 4x. When we divide, x is 6. Last thing we want to do is find BD. So BD is these two segments together. So BD is going to equal 2 times 6 plus 5 plus 5 times 6 minus 4. So that equals 12 plus 5 plus 30 minus 4. So when we add those together, 12 plus 5 plus 30 minus 4, we get a length of 43. In number 4, we're going to have to draw a picture. So B is between AC. So in number 4, we have B is between A and C. So AC is going to be our endpoints of our segment, and B is going to be in the middle. We know that AB is x squared minus 2x. BC is 5x minus 6, and our whole length is 22. So just because it's between, it doesn't mean that it's directly in the middle, it just means it's somewhere on that segment. Okay, so in this case, I drew B a little closer to A. It could also be a little closer to C. It could be in the middle, we don't know. So when we are solving using segment addition, our two pieces, x squared minus 2x plus 5x minus 6 is equal to 22. So we have x squared plus 3x minus 6 is equal to 22. In order to factor, we need our equation to equal 0. So we're going to move 22 to the other side. X squared plus 3x minus 28 is equal to 0. So we need two numbers that multiply to 28 and add to 3. So that's going to be x plus 7 and x minus 4. When we switch our signs in, we get x is negative 7 and x is positive 4. In this case, if I take negative 7 and I put it into 5 times negative 7 minus 6, I'm going to get a negative number because 5 times negative 7 minus 6 is negative 41. So that number is out. So x is only going to equal 4. So if I want to find BC, I'm just going to put 4 in. So BC is equal to 5 times 4 minus 6, which is 20 minus 6, so that is 14. In number 5, solve for x and y. So if I look at this, I have two larger segments. I have this larger segment, or smaller segments. I have this segment that's 16 in length, and I have this segment that's 21 in length. So I'm going to write two equations. For the 16, the two pieces that are making up 16 are x and y. So we have x plus y equals 16. Can't do much to solve that yet because I have two variables. My other equation, though, is y plus 14 equals 21. In that case, I only have one variable, so I can solve for y first. I can subtract 14 from both sides, so y is 7. And then I can substitute in. So x plus 7 is equal to 16. When we subtract 7, x is 9. So we have our two variables solved for. In number 6, solve for x and y given that FB is 52 and FL is 78. So FB has a length of 52. It's using those two segments, so 3x plus 8 plus 35 minus 3y equals 52. I want to organize the equation so x and y are by itself, so I'm going to subtract 8 and 35 from 52. So we get 3x minus 3y is equal to 9. We also know that FL is 78. So we need all three pieces to equal 78. So we have 3x plus 8 plus 35 minus 3y plus 2x plus 3y is equal to 78. So when we go to combine our like terms, we have 5x. The y's cancel out, so those are not left. Plus 43 is equal to 78. So we can subtract 43 from both sides. 5x is equal to 35. So I can keep solving that to get that x is 7. Once I know x is 7, I can substitute into our other equation. So 3 times 7 minus 3y is equal to 9. 21 minus 3y equals 9. We can subtract 21, so negative 3y is equal to negative 12. So when we divide, y is 4. So we have x is 7 and y is 4.